Okay, folks, so in this video, you know what was coming. We talked about the humidifier in the previous video, and now we are going to talk about the dehumidifier. That's right. For some reason, and we'll figure that out in just a minute or two, this instrument has included a humidifier, and then it includes a dehumidifier at the very end of the instrument, or the schematic that we've seen over and over. All right, so here's the schematic, and we need to talk about the location of this dehumidifier, okay? So where is it? Well, we've talked about the location of the humidifier, which is right here. The dehumidifier is going to happen at the very end. So at spot number 12 in this schematic, that is where you're going to find the dehumidifier. So if we kind of track through the sample, here's the 8-point valve that goes into the syringe, then that goes into the combustion tube with the catalyst. CO2 is produced here. CO2 goes through this, what we call a purified water trap, and then it goes into the dehumidifier box. All right, so the dehumidifier is going to happen before the NDIR detector. And there's a couple of other pieces too that we're going to discuss before we finish up this lecture series. But what I need you to know is that the dehumidifier is before the detector, and it's also before what we are going to talk about a little bit later, the halogen scrubber. All right, so there's got to be a reason, there's got to be a purpose in the dehumidifier. Why is it at the location that it's in? And not only that, but look at this. On this dehumidifier, there is a line that comes out from that box, and this line goes into what we call a drain pot. So we need to talk about the drain pot too. Right now is the perfect time to discuss that attachment as well and where to find that attachment. Okay, so let's take a look at the dehumidifier before we go into a little bit more detail. Here's the dehumidifier and the dehumidifier fan. There's actually two pieces that this setup kind of requires, and the dehumidifier is as expensive as the detector. I mean, look at that, over $2,000 for the dehumidifier. And you're seeing kind of a one version of the dehumidifier up here at the very top. The fan that also drives this dehumidifier in order to work can also be replaced, because that can also go bad. You can kind of imagine that motor on the fan going out, and it has to be replaced so the fan blades can move again. And that's a little bit cheaper, and that's a $90 price tag. So by and large, two things that I do not want to go out on the instrument. And the first one is going to be my detector, of course. The second one is going to be my dehumidifier, because those two are quite a large chunk of money, over $2,000 a piece. Now, why? Okay, we need to talk about why a dehumidifier is actually attached to the instrument. And the purpose here is very similar to the purpose of the humidifier that we've talked about before. Anytime this instrument or this sample has extra moisture that doesn't need to be there, that extra moisture has to be removed. And in particular, it has to be removed before it goes into the detector. And one of the reasons is because water can actually destroy or slowly destroy the NDIR detector if I'm not careful. So if something's going out, and that's my dehumidifier, it is not removing the extra water that's from my CO2 as it pumps out of that combustion tube. And that extra moisture can make its way into the detector, and that extra moisture will start to corrode the inside of that detector and begin to make it to malfunction. And now all of a sudden, my wrong or improper dehumidifier that's costing $2,000 will now somewhat destroy my NDIR detector. That's another $2,000. So that could be a $4,000 repair bill on my hands if I'm not careful. So the concept is, yes, all right, if I go back to the schematic, we do have a humidifier, and the humidifier's purpose is to give this constant moisture throughout the entire analysis every day with every sample. And then at the end of this, before it goes into the detector, any extra moisture that still might be there, that has to be removed. And that's the dehumidifier's job. It's got to remove the extra moisture that's in my sample throughout the analysis runs. So that dehumidifier will take out the extra moisture, and of course moisture is water, and it's got to go somewhere, okay? So this water vapor is going to condense down, and when this thing begins to condense down into a liquid, it's got to have somewhere to go. And all of that extra moisture will go into what we are calling the drain pot that's down here at the very bottom of the schematic. The drain pot, it's just basically a vessel. That's all that it is. It's just a piece of plastic with a plastic lid, and this is holding all of the moisture that's getting generated by the dehumidifier. Where is the drain pot going to be located, right? Well, the drain pot is going to be located on the side of the instrument where you found the hydrochloric acid bottle, okay? It's really in the same setup. Again, I told you there's a couple of bottles at least on the side, and the drain pot is going to be one of them. So for instance, this could be my hydrochloric acid bottle that the TOC uses to squirt in my sample to ensure that the release of the CO2 is going to go forward. And beside of that, you're going to see another tube, typically fairly tall, with a plastic rubbery type of lid on the top of it. And on the side, you'll see a drain arm, and I'm coloring that in blue on the screen for you. All right, so this is the drain arm, and that is where all of the extra moisture will eventually leave out of the drain pot and go into a waste bucket that's hopefully down below. Here's the weird thing about this, though. All right, the reason that I'm pointing this out is that this drain pot, and that's what we're calling this, that's how the schematic labels it, that's what we'll also call it as well, that drain pot has to be filled in order for it to work the proper way. I know that sounds kind of strange and weird, but in order for this TOC machine to work, and in order for the dehumidifier to work properly, we really do want that drain pot filled all the way to that drain level or the sidearm with DI water. So I'm going to go and I'm going to get a DI water bottle again, and I'm going to bring it over. And probably when I check the humidifier, I want to check the dehumidifier level, and I want to ensure that that water level is up to the sidearm piece, so therefore it can drain. If not, then it's pretty easy to do. The only thing that you have to do is pop open that rubbery type of lid that's going to be seated on it, and you'll just take a DI water bottle or a beaker or something that's filled with DI or distilled water, and you just fill it all the way up to the top. And when I keep talking about this sidearm, I'm talking about the drain hose, of course, that's going to be right there. So here is where you would want to fill it. So I normally add enough water until I visually see some of the water that I'm adding in to kind of go through and drain into the waste container that sits down below. But that does go to the dehumidifier part. A lot of people just do not know that, but that is what the purpose of that vessel is for. So that is the dehumidifier. That is one of the exit chambers out of the machine. It's got to go somewhere, and it normally goes into a bucket that sits down below. This exit point that we're talking about, the exit point is going to be the waste container. So this is where that sample is going to eventually end up, and all of that extra moisture is going to end up. So down below the TOC instrument, you will typically see some type of container. For us, it's just a simple bucket. For other people, it might be like a 4-liter jug that you would see some reagents come in. Instead of throwing those away, they might reuse those and use them as drain containers for equipment, and TOC could be one of them. But what you're seeing here is the TOC instrument up here at the very top, and of course this hose is from the drain pot. And that hose will take all of that extra moisture and all of that extra sample that doesn't get converted over, and it drains it out of the machine, and it takes it into a container that sits down onto the floor. Notice the way that they've drawn this tubing. Notice that this tubing kind of comes out and straight down. We don't make any humps or mountains in the tubing. And the reason is because it will prevent the drainage from happening. So if you look at these dotted lines, you can see a dotted line, and if I just connect them, you'll see kind of a hump in the hose if you are allowed to do that. This is not recommended, and it will actually kind of back up everything inside of your machine. So you do not want to do this. You want to make sure that that drain hose is pointed somewhat straight down. You do not want any kinks. You do not want any humps. You don't want any elevation in that tubing, because your instrument will not drain the proper way. Instead, what happens is that the moisture will begin to back up in this area, and that moisture will begin to go back up into your drain pot and prevent it from draining. And that's the whole purpose of the drain pot. That's why we call it the drain pot. We want it to drain. We don't want it to back up and get stopped up because you're having some kind of kinky hose in the lab. So just pay attention to it. Make sure that you are just double checking some of the tubing and some of the drain lines whenever you go over and use the instrument, so that way this does not happen on you. All right, so a couple of pieces here. The drain pot, we now know that's where the waste goes inside of my TOC instrument. That drain pot has to be filled with DI water or distilled water until I physically see it drain, and then I can start running samples on it. That's one of the kind of the checks or the pre-checks that we do on the piece of equipment. And if I look at the schematic, both of those are going to be included side by side. So I'll see the dehumidifier up here at the top, and then I see the drain pot down here that sits below. So once again, if I give you the schematic and I'll white out these areas and I have you to label them, hopefully you can go through and label where the dehumidifier is going to be at, and you can label where the drain pot is going to be at as well. All right, I'm not going to show you a video of replacing the dehumidifier because, quite honestly, it's very difficult to get to sometimes, and we just really don't tamper with the dehumidifier unless we absolutely have to. This piece is not really going to go bad quite often unless you just have a malfunctioning piece of equipment. This is somewhat harder to get to than the actual detector is going to be. So that's what I need to say about the dehumidifier. If you are interested in replacing the dehumidifier, there's probably someone at your company that has done this before. If not, they probably have a preventative maintenance schedule with Shimatsu, and we call that a PM agreement. And that preventative maintenance allows them to come in and double check to make sure the dehumidifier is working and that some of the other pieces and parts are working the proper way as well. So you're not caught off guard one day when you go over to the TOC instrument and something's not working out for you. So that's what I need to say about the dehumidifier. It takes out all of the extra moisture that you might find in your sample as these samples are processing. It registers that extra moisture. It knows if it's there. It removes all of that water vapor in form of a liquid water, and then that will eventually get dumped into the bucket that sits down below. So a couple of different reasons why this thing is kind of important. All right. So dehumidifier, not one of the cheapest pieces that you can replace. Again, almost, if not more expensive than the detector. And if something does go bad here, you hope it's the fan and you hope it's not the actual dehumidifier itself. All right, so there's the story with the dehumidifier and the drain pot. And if we look at the schematic, again, let me pull it up. What we are seeing else that's on here that we've not talked about yet is this purified water trap and a halogen scrubber and a filter. So I want to take a few minutes And I want to talk about those pieces as well, because that is part of the schematic. That is a piece of preventive maintenance that you can do on this TOC instrument. And I'll tell you a little bit about each one of those and how to change out those pieces if you need to. So in the next video, we are going to focus on the halogen scrubber. And the halogen scrubber is number 10. So that is what we're going to focus on next. So the halogen scrubber is the piece that is in between the dehumidifier as well as the NDIR detector. So that's where our focus is going to be on in the next video. Don't walk away from me. Keep out your notepad, keep out your pen, keep taking notes. You're doing a great job. It's almost over. And next, we'll talk about the scrubber.